In number 5, we want to rationalize the denominator. So in order to do that, we're going to multiply the numerator and denominator by the conjugate, 4 minus 5i, the conjugate of the denominator, okay? Now, for the denominator, it comes from a special product. Remember, a plus bi times a minus bi multiplies into a squared plus b squared. Okay, so in this case, it would be 4 squared plus 5 squared. Alternatively, you can just distribute and use FOIL to multiply these. You would get the same result. As a matter of fact, we're going to do that for the numerator. We have to. 2 times 4 is 8. 2 times negative 5i is minus 10i. And then negative 3i times 4 is negative 12i. And then negative 3i times negative 5i is plus 15i. Plus 15i. Okay. Plus 15i squared, rather. Now, combining like terms, the complex terms, negative 10i and negative 12i, those two combine to give minus 22i. And then plus, remember we can replace the I squared with negative 1, so we would get minus 15 here. The denominator is 16 plus 25. Now going back to the numerator, we can combine like terms. 8 minus 15 is negative 7 minus 22i over 16 plus 25 is 41. Now to write the answers in standard form, we break this up, negative 7 over 41 minus 22 over 41i. And that's the final answer. In number 6, we want to graph this quadratic function using transformations or properties. I'm going to graph it using properties. So first I identify a. A is 1, that's the coefficient of x squared. B is 4, and C is 7. Okay? Now the vertex comes from minus b over 2a, and then minus, for the y-coordinate, it's minus the discriminant over 4a. Okay? So for the vertex x-coordinate, negative b over 2a, that's negative 4 over 2, which is negative 2. And then let's calculate the discriminant here separately. It's also going to give us some interesting information. B squared minus 4ac. B squared is 16 minus 4 times a, 4 times 1 is 4 times 7 is 28. And that's negative. And 16 minus 28 is negative 12. Okay. So negative 12 divided by 4a, it's negative 3. So we got the answer for the vertex. It's negative 2 comma negative 3. So the next thing is, oh, I'm sorry, there's an extra negative here we have to do, right? So it'll be negative the discriminant over 4. So what does that give you? Let's see here, negative 2 comma positive 3. Okay, great. So positive 3 for the vertex. The axis of symmetry is a vertical line, so it's the equation is x equals, and of course it has to go through the vertex, so we have to pick negative 2. Now, because a is positive, we know that the parabola is going to open upward. And then because the discriminant is negative, we know that it's going to have no x-intercepts. Let's see if this makes sense. Let's go here and draw our xy axis. So I'll put the x-axis here. Let's fix that. And then the y-axis here. Here we go. And then we'll label the vertex at negative 2 comma 3. That's the vertex. And then let me draw the axis of symmetry. It's a line that goes through the vertex like that. That's the axis of symmetry. We'll label this as v 2 comma negative 3, and x equals negative 2 is the axis of symmetry. And then we can choose the points. So one of the things we can figure out is the y-intercept is a property, and it comes from just plugging in 0 into the function. So that's 0, 7. So 0, 7 is the y-intercept. So here we go. This is 3, 4, 5, 6, 7. So 0, 7. And because of symmetry, we can go the other way, 2 units, and we know we have another point there. Okay? And so now I can just graph my parabola as such and answer the rest of the question. So the domain is, of course, all real numbers, and the range are the y values. I made a typo over there. Let's fix it. It's actually what we have up there, which is negative 2 comma positive 3. Okay, so the lowest y value is 3, and it goes upwards, so there is no largest value. It's 3 comma infinity. Okay, let's take a look at the next question, number 7. Number 7 says graph the solution of the inequality 3x minus 6y is less than 2y. So remember, we have to shade part of the xy plane based on a line that separates the xy plane into 2 pieces. Now, because we have a soft inequality, not equal, we're going to draw a dashed line that comes from just changing the less than sign to an equal sign. And one way to do this is to write it in slope-intercept form, which is y equals 3 over 2x minus 3. So if I put my xy axis here, let's fix this, then the y-intercept is negative 3, which is right here. And then the slope is 3 over 2, so we can rise 3 units for every 2 units to the right. So go up and right, okay? And then we can draw our line. But we have to draw the line dashed. Okay, let's clean this up. So the next thing we're going to do is we're going to choose a test point. The test point can be any point in the xy plane that is not on the line. So I like to pick the origin because it's available. It's not on the line, so it's a valid test point. Now the test point has to be plugged into the original inequality. 3 times 0 minus 6 is less than 2 times 0. So I'm plugging in the x here and the y here. And the question is this true or false? Let's see. That 0 minus 6 is negative 6, less than 2 times 0 is 0. Is that true? Yes, it is. So wherever we tested the test point, which is right here, that is the region that we're going to shade to the left. So the answer to this question is to shade everything to the left. In number 8, we have to solve an absolute value inequality. Now the key is to isolate the absolute value portion. The absolute value portion is this part here, without the 2. Okay? Now a common mistake here people do is they just subtract 5 minus 2, which is wrong because it doesn't follow the order of operations. There's a multiplication here, so you can't do the subtraction. Instead, to get rid of 5, we're going to subtract 5 from both sides. So we're left with negative 2 absolute 4x plus 3 is less than negative 4. And then we're going to divide both sides by this negative 2 to get rid of it. And here's the trick to remember. When we're working with inequalities, when you divide by a negative number, you have to reverse the direction of the inequality in that step. Okay, so we're left with absolute 4x plus 3 is greater than positive 2. And we know from class that when an absolute value is greater than a number, it produces an OR compound inequality, a conjunction. 4x plus 3 is less than negative 2, or 4x plus 3 is greater than positive 2. Solving this inequality, subtract 3 on both sides and then divide by 4. X is less than 5/4, or subtract 3 on both sides and divide by 4. There we go. And then we need to graph the solution set on a number line. So here's a number line. Here is 0. Here is 1/4, 2/4, 3/4, 4/4, 5/4, 6/4. Negative 6 over 4, negative 5/4, negative 1, negative 3/4, negative 2/4, negative 1/4, positive 1/4, positive 2/4, etc. So now the first inequality is x is less than negative 5/4. So I'm going to mark my negative 5/4 right here, and I'm going to draw an arrow to the left. And then for the other one, here is negative 1/4 and greater than that, so I have to mark it to the right. So that's a graph of the solution set. In interval notation, since these two inequalities don't have anything in common, we're going to use a union. The one on the left is negative infinity comma negative 5/4, parentheses, not a bracket, because those circles aren't filled in, and then negative 1/4 comma infinity for the other direction. So this is the solution set in interval notation, and this is the solution set on the number line, a graph of the solution set.